Dear children, today's lesson is about dimensions of physical quantities. Do you hear these words length, mass, time, temperature, and all these are known as physical quantities. We will measure them in meters, grams, minutes, kelvins, respectively. That means these are their units. Okay, so these are the base physical quantities in physical world. Base means they are independent, they are not depend on other physical quantities, but there are some after that there are some derived quantities. That means those quantities are came from the base quantities. They are area, volume, density, frequency, velocity, acceleration, force, impulse. In today's lesson, there are so many physical quantities are there. In this lesson, in today's lesson, we will learn about these. Okay. So first, let us go for area. What is area? Area is the place occupied by an object in a surface. So if you take a paper and if you place it on a table, then we will say how much place this paper has occupied on the table. That will give you the area of that paper. How do you measure the area of the paper? You will measure the length and breadth of the paper and you will find its product. So length into breadth will give you the area of the paper. This we know from our earlier lessons. But length is in our physics, length is also a physical quantity, breadth is also the same length physical quantity only. We will take measuring the distance from 2 points will give you the physical quantity length. We will take it as physical quantity length. So length into breadth. That means we will take here length into length only. So the dimension of area will be, we will denote all the dimensions of every physical quantity using square brackets, and length we will denote with capital L. So area's dimensions are in square brackets we will write like this: L to the power of 2. Okay, L is raised for 2. Why it is raised for 2? Because we will get area by multiplying length and again by length only. Okay, so next coming to our next physical quantity, volume. How will you find the volume here? Again, volume is a, you know already, volume is a three-dimensional quantity. So in that you will have three measurements: length, breadth, and you will have height also. So we will get the volume of, suppose this, if you take this our classroom as an object, here this is the length, this is the breadth, and this is the height of our classroom. So if you multiply these three quantities, you will get the volume of our classroom. So yeah, what is the dimension of this physical quantity, volume? Again, we will say length is suppose 100 meters and breadth is suppose 50 meters and our height is say suppose 20 meters. Then all are our length only, physical quantity length only. So we will say that volume is length into length into length. So what will be its dimension formula? We will, as we know, the dimension formulas are denoted with write in square brackets. So with write in square brackets, L raised by 3 here. So the volumes dimensions are L to the power of 3. Now coming to mass density. Do you any of you know the formula of density? Yes, you are right. Mass density formula is mass per volume. So How do you find the dimensions for mass per volume? Now coming to mass. How do you find the mass? Mass is in our SI units, we will denote with the grams. So the physical dimensions of mass we will denote with capital M. So mass is capital M. And volumes, physical quantity, just now we have found as L raised by 3. So mass per volume means M by L to the power of minus L to the power of 3, which we can write it as M times L to the power of minus 3. We should keep them in square brackets to find the dimensions of mass density. All of you understood, I think. Next, coming to frequency. Anybody knows the definition of a frequency? Definition, what is the frequency? Number of oscillations done in 1 second is called the frequency of a particular object. So, that here what is the formula for frequency? 1 by time period. So, its dimensions are what? 1 by the square, in square brackets we have to write T for time period. So the frequency's total dimensions are 1 by T. Next coming, the next point, next for physical quantity is velocity. What is the formula of velocity? Velocity is displacement by time. So its dimensions are, the displacement we will measure in meters. So it is denoted with L. Its physical dimensions are capital square brackets L, capital L, by time is in square brackets T. So totally the dimensions of velocity are L by T. Next physical quantity is acceleration. Anybody knows the formula of acceleration? Very good. Acceleration is velocity by time. So, what are the physical quantity for velocity? Just now we have found L into t to the power of minus 1. That divided by t will give you L t to the power of minus 2. So, totally the physical quantity acceleration's dimensions are L t to the power of minus 2. And the next physical quantity we are learning is force. Anybody knows the formula of force? Yes, you are right. Force is equal to mass into acceleration. Just now we have found the dimensions of acceleration. So now what can anybody tell what is the dimensions for force? Yes, you are right. Mass m into L t to the power of minus 2. That will be the total dimensions of physical quantity force. Very good. Then the last thing for today's class is impulse. Anybody knows the formula of impulse? Impulse will be force into time. So what is the dimension we got for force? M L t to the power of minus 2. So finally the impulse dimensions are M L t to the power of minus 2 by into t, which will be equal to M L t to the power of minus 1. I hope all of you understand area, volume, density, frequency, velocity, acceleration, force and impulse, their formulae and their dimensions. Okay, like this there are so many physical quantities are there and their dimensions we have to know to do more numericals in our physics. Thank you.